Hi everyone, so here we are on Chapter 4, Day 2. We ended the last lecture on acids and bases and how strong acids and strong bases can also be classified as strong electrolytes. So let's talk more about that and how you can determine or distinguish between them and what makes an acid strong and what makes an acid weak. Alright, so first let's talk about our strong acids. So your strong acids will completely dissociate in water. Okay, besides dissociate, we might say ionize, or they will completely break apart into their ions. All right. And so here are some examples: hydrochloric acid and sulfuric acid. So if you remember, those acids are on your strong acid list. So once again, make sure you have those memorized. If they're not one of those 5 or 6 acids that I gave you, then you are going to consider it to be a weak acid. Now let's talk about your weak acids. So weak acids will only dissociate to a very small extent. Okay, so most of the acid will actually stay together, and it's only like 1% or less than 1% will actually break apart into their ions. Okay, and then therefore there are some examples listed: acetic acid, which is found in vinegar, and formic acid. Okay, now here's a picture. If you take a look at this picture on the left, all right, you can see that all of the ions are completely separated. Okay, and this is an example of hydrochloric acid, and you know hydrochloric acid is a strong acid. Okay, so once again, strong acids will completely ionize in solution. Now if we take a look at this other one here on the right, this is an example of a weak acid. And from the picture you can see that, because notice here, okay, right there, those, see how that is the only one that separated into ions in solution. Most of these other molecules, right, are together still. So only a very small amount of it actually ionized. And that's why that one is an example of a weak acid. All right, so now let's talk about your bases. So you should know the difference between a strong base and a weak base. So once again, you already have the list in the notes from the previous lecture. So remember, a strong base is where you have a metal from group 1 or 2, except for magnesium, and that has to be combined with hydroxide. So on your paper, on your notes, I know this looks like a funny little shape here, and that's because when the PowerPoint gets loaded in this program, it doesn't like certain characters or superscripts and subscripts and stuff, so it turns it into these funny characters. So this is hydroxide, OH minus. Okay, that's OH minus. All right, so strong bases basically is very similar to a strong acid. So a strong base will completely ionize in solution. The ions will be completely separated. Okay? And then a weak base is the opposite. A weak base will not completely ionize. Only a very small extent of it will actually dissociate into ions. All right? One of the things here listed for a weak acid is ammonia. Ammonia is NH3. You need to recognize this as being a weak base. It's one of your bases that does not have hydroxide in the formula. All right? And you will see throughout AP Chem that there are also other NH compounds that are weak bases. So here's a picture of weak bases and strong bases and what the picture might look like if they were to dissolve in water. So then obviously on this side here, sodium hydroxide, we know that is a strong base. Okay, see how the ions are completely separated. They are free-flowing in solution. That also demonstrates why your strong bases are strong electrolytes. Then you take a look on the right side. Oops, pen option. This is a weak base. All right, notice it was only that one that separated into ions. All the other molecules here, right, are still together. Okay, and that's why this is considered a weak electrolyte, because it doesn't have very many ions in solution. All right, you also need to be familiar with molarity. Remember, molarity is your concentration. You need to have your equation here memorized. You should already know this, right? Molarity is moles per liter. Don't forget, this is a capital M that represents that. So let's just kind of do this practice problem to refresh your memory. So then this is the question, what is the concentration of a solution that has 6 moles of sodium chloride in 500 mils of water? So the answer is already listed there, but let's go through the work. So we write out our equation. Molarity is moles per liter. Plug in the numbers that were given. 6 moles will go on top. And then notice here that the 500 mils, the volume is provided for you in milliliters. We have to convert that to liters. So when we use this equation, the volume has to be in liters. All right, so you're going to move the decimal here 3 places to the left. So it becomes 0.5 liters. All right, so we plug that into your calculator. You should practice plugging that into your calculator, and then you should get 12 molarity. Here are some terms that you should know when we are talking about our solutions. So we will refer to stock solutions as the solutions that are typically higher in concentration. So we typically keep these so-called stock solutions, or referred to as standard solutions, on the shelf in higher concentration because we can easily dilute it just by adding water. All right? You should also know by now the terms concentrated and dilute. So concentrated and dilute refer to the amount of solute versus the amount of solvent. Okay? So if something is very concentrated, that means it contains a lot of solute. All right, it contains a lot of solute and very little solvent. On the other hand, a solution that is dilute has a lot of solvent and very little solute. Okay, so make sure you know the definitions of those terms. All right, so this equation here, M1V1 equals M2V2. Once again, these should be little subscripts. It is written correctly in your notes. So this is a dilution equation. So with this dilution equation, if you take a look at it, molarity, once again, remember, is, moles per liter, right? So in other words, if we have the molarity, which is moles per liter, times the volume, notice what happens here. The liters cross out, leaving you with moles. So what this equation is saying, it's saying that the moles that you start off with are going to be the same amount of moles that you end up with when you're doing a dilution. Okay? All right, so let's read this problem. I know the work is already shown there, but you should try to do it on your own to see if you understand it and you can do it by yourself. All right, so what volume of 12 molar hydrochloric acid must be used to prepare 600 mils of a 0.3 molar hydrochloric acid solution. So you can see that this is a dilution. We're starting off with a stock solution of 12 molar, which is very high, and we're going to dilute it down to 0.3. Okay? So you just need to pair the information up correctly. So then you're going to use your M1V1, which equals M2V2. So then what volume of 12 molar? Notice that will go together. All right, so we know that's 12, and then the volume for that we are solving, so that's X. You keep reading, fill in the rest of the information. You'll notice that those are paired up. So that molarity is 0.3. And then this will be 600 mils. When you use this equation, you can leave your volume in milliliters. That is perfectly fine for this equation. All right, so then you just rearrange the equation. You're going to solve for x. Okay, so you're going to divide by 12 on both sides. All right, and then you should end up with the answer that's there with 15 mils. All right, so this type of equation I use all the time because I'm making your solutions for labs and stuff. So what this is saying, remember what we were solving for. We were solving for how much, right, the volume, how much of the stock solution are we going to use. So through the calculation, we calculated that we need 15 mils of the 12 molar hydrochloric acid. Okay, now in the end, we want 0.3 molar solution and 600 mils of it. Okay, so then we're only using 15 mils of the stock solution, then the rest of it is going to be water. We're going to dilute it, so we add a lot of water until we get to the 600 mil mark. So in order to do a dilution, we will most likely use a volumetric flask. So this is called a volumetric flask. Notice on the volumetric flask it only has one line or one like calibration mark on it. And these volumetric flasks come in many different sizes, all right? So then we would find the appropriate size for the dilution and the amount of solution that we are looking for, okay? You can add in a solute, whether it's a solid or whether it's a solution, all right? You would add in your solute, add some water, put the stopper on it. You can shake it or you can stir it. So once it dissolves, then you can fill the rest up with water until you reach the line, all right? Okay, so this is where we left off on the help sheet. So let's take a look here. This information that's provided for you right there, those are some terms. You should read them. There's equivalence point and there is the term end point. Oops, move that back. All right, end point. Okay, so then once again, moles of acid equals moles of base. That is basically what happens at the equivalence point. Okay, now when we reach the end point, all right, when we reach this end point here, that's where the indicator changes color. So when you're doing a titration, the indicator will change color to let you know that you have reached the equivalence point. So these two equations here are really important for you to know. Okay, at the equivalence point, moles of acid equals moles of base, and then MAVA equals MBVB. So we used this equation last year, but there's a slight variation. Notice it has these little number signs, or which are referred to as pound signs when I was growing up, which you guys refer to as hashtags right now. Okay, so by adding this is telling you that, well, first off, let me explain. These little A's here represent acid, and then the B's on this side represent base. So the acid information, you're going to multiply by the number of hydrogens in the acid formula. The base information is going to be multiplied by the number of hydroxides in the base chemical formula. All right, so we'll do an example here. So using this equation works really well when the solution is being neutralized, but it's sometimes hard for you to remember to use this equation. You can always solve the problem using stoichiometry and using the concept moles of acid equals moles of base. But definitely it's much easier just to use this equation if you can remember it. All right, okay, so this problem here, question is what volume of a 0.1 molar hydrochloric solution needed to neutralize 25 mils of a 0.35 aluminum hydroxide. Okay, so we're going to use our equation. So we're using this equation right here. So let's write that down. number MAVA equals the number of MBVB. VB. All right, so now let's plug in our numbers and all of the information into the problem. So remember, we start off with the number here, or the hashtag, or whatever you want to call it. So this is for the acid information. So notice on the acid information, all right, so how many H's are in the chemical formula? So that's what the number sign represents again, the number of H's in the acid chemical formula. So that one only has 1. Okay, so we're going to plug in 1 times the next thing, which is the molarity. It's given to us in the problem right there. And then we're solving for volume, so that's X. All right, let's go to the next thing. The number here, which represents the number of hydroxides in the base chemical formula. So then, it's right here, aluminum hydroxide, OH, right, represents the base, and there are 3 of them. So then, that will be 3. Okay, times the molarity of the base, which is 0.35. Just move this over. And then times the volume of the base, which was 25. All right, so finish out the algebra and solve for X, okay? And we will go over that answer tomorrow in class to see if you did that correctly. Just remind me. All right, then this last problem here, that is on the help sheet. We will actually also do this one in class tomorrow. All right, so that is everything for tonight, and I will see you tomorrow. Bye.